Hello class, here's a little demonstration on how you can use your TI-8384 calculator to determine probabilities from a normal distribution. And all we need to know, we completely define the normal distribution if we know the mean and the standard deviation. And if it's a standard normal distribution, then of course that's a 0 and that's a 1. But we're going to work with some other distribution, and let's say it's got 98.2 is the mean, and we'll say let's say 1.05 is the standard deviation. And we want to know for this random variable, this normal random variable, whether or what the probability of getting some value from this distribution. Let's say it's something to do with temperatures. Okay, so what's the probability? Here's our mean of 98.2. One above, one below. So this would be like 99.25. And then take away the 1.5. I'm sorry, 1.05. 97.15. Okay, let's calculate a probability that or a proportion of the population that has this temperature greater than 98.5. Okay, 98.5 is somewhere around here. So we're looking for this region. We know it's going to be smaller than 50% or 0.5 because that would be right at the mean. So let's go ahead and type this into the calculator. The way you get to this function is the second vars takes you to the distribution. So my blue key gives me the blue option, which is distribution, and the second is your normal CDF, and it just wants the lower bound. So our lower bound is the 98.5, and then it wants an upper bound. The calculator's largest number is reached in scientific notation. We'll just say 1 times 10 to the 99th power. And then, of course, we need the mean of 98.2 and the standard deviation of 1.05. Okay, so 98.5, upper bound, you get to that, you just hit a 1, and then you do a second function, and then above this here, that EE option, and then 99, so that's calculator infinity. And then we're going to change to 98.2 for the mean and 1.05 for the standard deviation. Okay, so the region we've shaded represents about 39 if we round to the nearest two places. So that's roughly 0.39 area. So that represents the probability of randomly selecting an individual greater than or equal to 95. It also represents the proportion of the population that's greater than 98.5. Okay, another thing I'd like to show you is, let's say that we want to know what value, and we don't know what this is yet. So we're going to ask, what value do I need for my distribution that would represent an area to its left, let's go with to its left of 0.28. So what value has 28% of the population below it if I've got a normal distribution with this mean and the standard deviation? So we can do that inversely. So we're going to go to the same distribution menu and choose this third option, which stands for inverse norm. And we need to give it the area, so that's what this is, the area or the probability or the percentage of the population. So we're going to start with the 0.28. Our mean is 98.2. And then 1.05. And so since we're interested in less than, we're going to go with the left tail. So if you wanted a greater than, we would go with the right tail. Okay, if we had changed this to a greater than, we'd be using the right tail. Center just means how far do I go on each side of the mean to get this area. So we're interested in the left tail, so I'm going to go ahead and move down here and hit enter, and it says 97.58. So this would mean that the probability that x is below 97.59, if we round, is about equal to the 0.28. So we found it the other way around. And one last quick thing, if I wanted to use a standard normal, remember in standard normal we have a mean of 0 and standard deviation of 1. And let's say I'm working with a z-score and I want to know the probability that z, well, let's go with it between. Let's say the probability that negative 1.2 is less than z is less than, let's say 1.7. Okay, so we're somewhere in the middle of that, right? If this is 0 and this is 1 and this is negative 1, we're going from about right here to about right here, 1.7. Okay, so we're finding a pretty significant area, so it should come in pretty large. Now I'm just going to use the calculator and go back to my second distribution and choose normal CDF, but I just need to put in, I don't have a lower bound on either negative infinity. Negative infinity is negative 1e 99. Positive infinity is positive 1e 99. I'm going between negative 1.2 and 1.7. So my lower bound is negative 1.2. My upper bound is 1.7. And since I'm in standard normal, I'm going to use the mean of 0, standard deviation of 1. Okay, and it comes out to be a pretty large percentage, so that's 0.84. So 84% of the population is between negative 1.2 and 1.7. Likewise, if I randomly selected from the population, the probability I would get somebody that's within this range is 0.84.